Good morning, students. So today we shall discuss about stack. What is stack? So in the previous video I explained traversal of linked list. So in continuation of that, today we'll discuss about stack, and then what is push and pop operation. Okay, what is stop, what is LIFO, that is last in first out, and through some pictorial diagrams I'll explain how implementation of stack is done using array. Okay, so first, what is stack? Stack is a linear linked data structure in which insertion and deletion of data can take place only at one end of the list called top. So the first part is just a theoretical explanation. Okay, I'll later on I'll explain with the pictorial diagram to make you understand much better. Okay, so we have already gone through this linear linked list data structure, so I'm sure that you have understood that. Okay, so stack is another type of linked list data structure, okay, where you can insert data in and delete data, but from only one open end from the stack list, that is the top. It is called as the top. Okay, so what is last in first out? Stack is also called as last in first out. So that is the last item inserted or pushed into the stack is the first item to remove or popped out from the stack. So since in a stack there is only one open end from where the data can be inserted or it can be removed, okay, so it is called as, if you insert the data from the top, so it will be inserted from the top, so it will be called as push. But if you remove it from the top, it is called as pop. That is, if suppose you have in that is in an array element, suppose you have say like the data in an array element, you have the data value 1 2 3 4, and 1 is at the bottom, that is the close end, and 4 is at the top, that is at the open end. So 4, since 4 is the last data that was inserted, so when you pop it, okay, 4 will be the first data to be removed. So if you want to remove 2, right, so after 2 comes 3 and 4. So if you want to remove 2, since it is last in first out method and it is in an ordered list, okay, so in a stack the data is in an ordered list, so it will be removed one by one. So 4 will be removed, 3 will be removed, and then after that 2 will be removed. So in the stack you will have only one data element, that is 1. Clear? So in order to remove 2, the 2 data element, you have to remove 4, which is at the top, and 3, which is at the top of 2. So it will be in the format of last in first out. Clear? So what is push and pop? So the operations can be that can be performed on stack are push and pop. So when an element is added on the top of the stack, the operation is called as push. So when you insert a new element from the top, you call it as push. And when an element is removed from the top of the stack, the operation is called as pop. Okay, so you just remember what is push and pop. You inserted a new element, you call it as push. You remove an element from the stack, you call it as pop, right? So a stack is represented in the following form. So using a pictorial diagram, you can get a much better understanding. Okay, so here you can see that in this diagram, this is how a stack is arranged. So here you can see that the data 1 is the first data that is pushed in, okay, into the stack, and data 2, so this here is actually your array elements. Okay, so you have 4 array elements. 4 array elements. This is array index 0, this is array index 1, this is array index 2, and this is array index 3. So here, so the top, that is, this is actually a function. Okay, so here stack has only one open end from where data will be inserted, push or remove, pop. So stack stores data of similar data types, that is, if you are inserting integer, so it will insert integer values only. Okay, so top here is actually a function which is used to access the top data elements. So using this top function, you can access the data stored in the in these array elements, or you can insert, okay, or you can remove the data element from the top. So here this element is always kept open. Okay, this first array element is always kept open, and the first array element index is 0, which is occupied by this top function. Okay, so here this is top. Clear? So this top actually points to the address of this points to the data value here. Okay, so since you have to push or you have to insert the data, so you can insert the data from the top only, and since you have to remove or pop the data, you can remove it from the top only. So that is why this is always kept open. Okay, that is something like a door. Okay, if you you open the door, you can enter. You open the door, you can go out, like that. Okay, so this here, no datas are inserted here. Okay, no data values are stored here, because this is where the top uh, this is where the top function, from where it will be able to access the data elements. So here top element is left open for data insertion and deletion. Okay, so if you want to remove this tree, okay, so it will be, since this is the last data to be inserted, it will be removed, that is popped. Clear? So similarly, okay, it can be in this format also. Stack can be, so here the datas are stored, the maximum number first, so next, and then the minimum number last. So if you have to remove that, the minimum number will be removed first. Clear? So now another diagram, stack operation is performed as shown in the figures. Okay, so this is how a stack operation is performed. So you can see here the data, these are the variables. So the variables are inserted, so the variable stores the value. This may store, suppose, integer value 2, this may store integer value 3, like that, right? So when you so here push a means you're pushing the inserting the variable a. So this is the array element that stores the variable a, and this is also another array element, okay, which is occupied by the top. Okay, so top, so here top shows that, okay, it is pushing the variable a. Top function shows that it is pushing the variable a. That is why this block or this element is kept open. Okay, so again when you push p, okay, so two data elements are occupied now. Okay, so similarly you push c, again three data elements, that is you have push c, cba. So now you have push d. Okay, so let's just assume that this is the maximum array element that has been created. Okay, so that means the maximum array element here is 1 2 3 4 5, right? And top occupies the first index, that is index 0. So now you pop means you remove the element D. Again you remove the element C, pop C, right? So what happens is that when you remove the elements from the stack, you are actually emptying the stack, right? So that means now when you remove C, that means the maximum array element is 5. Now you have only two data elements, and the first data element is occupied by the top function, right? So now you have two data elements free. So since you have two data elements free, right, that is maximum is 5, since you have two data elements free, right? So when you can insert a new data, so that's why here push C, so a new data is inserted into the array element, so you have one more array element free. Now the concept of top is, okay, well, the concept of top here is, you can see that in here the maximum element is 5, so the top is also at 5, right? So when the element is removed, okay, what happens is that, okay, top, okay, will top will also get reduced down. Clear? It will be the top position will be after the last data element, okay, will be above the last data element. So it does not mean that the top will remain here at number 5. No, once you start removing the array elements, okay, it will move down as per the element that gets removed, because this top element, okay, it points to the address of the data value, right? It points to the address of the data value. That's why as the data elements gets removed, okay, the pop function will also, the pop element will also keep pushing down, will also keep one step down, and as it gets added, okay, the pop element will also push one step higher, one element higher. Clear? So basic operations on stack. So stacks can perform the following operation, that is creating of stacks. Okay, you can create stacks, check for stack empty stacks, so which is called as underflow. So if the stacks are empty, that means all the data elements are empty, then we call it as underflow. And if the stacks are full, so that means it is called as overflow. That means no data can be inserted into the stack, and in here data can be inserted into the stacks. So adding element in stack, that is called as push operation. Deleting elements in stack, that is called as pop operation. Okay, and you can print or display the data stored in the stack. Okay, so implementations of stack data structure. So stacks can be implemented by using array and linked list data structure. So the data structure is all about this unit is all about the array, linked list, data structure, and queues, right? So you can implement the stacks using the array and linked list, right? So first we shall see implementation of stacks using array data structure. Okay, so when implementing stacks using array must be given a size, that you must declare the array size always, because based on that only the data elements, how many data will be stored in data elements will be known. Clear? So if all the array elements are full of data, okay, then stack is said to be in full condition or overflow. That is just what I've explained. Okay, no more data can be entered. If all the array elements are empty, then stack is said to be in underflow condition. Okay, so how do we determine whether it is overflow or underflow? Okay, so overflow or underflow condition, it can be determined by checking the top of the stack. Okay, by checking the top of the stack. Why? Because the top, it occupies the first array element, that is the index 0, right? And from there only, accessing the data elements, okay, whether you want to insert or whether you want to remove, okay, it is done by the top, right? Top element. So now, so if you want to determine whether the stack is full or whether the stack is empty, it can be determined by using this top element. Okay, so there is an algorithm for this push operation, okay, which is in your textbook here. Okay, so if top equals to max minus, okay, this is max. Okay, if top equals to max, print stack is full, and then go to step 4. Okay, then step 2, top equals to top plus 1. Step 3, stack top equals to value, and then end. So if the value of top and max is same, okay, then that means that stack will be full, okay, and then it will end. But if suppose top is not equal to max, that means there is still some empty elements left in the stack, so which means that the top will increase by 1, so the top will move one step up higher. Okay, and then stack top equals to value, means this is the array element, right? Okay, so stack top, so if top is 5, so it will be stack 5, right? So that value will be stored in that new element. Okay, and top will take the next element after this stack top. Okay, so using a pictorial diagram, okay, I'll explain what this algorithm is about. Okay, so you can see here algorithm explained with an example. Okay, so here this is how the data are stored in the array element. Okay, so you can see here that the top 0, that is the index 0, is occupied by the top element. Okay, and here which actually points to the address of this data, right? Okay, so that's why this is kept open. Okay, this is kept open because if you want to remove this data, okay, so you have to access the address of where this data is stored, right? So that's why this element is kept open, okay, or kept blank, so no data is inserted, no data value is inserted here. Okay, so the actual data value that will be inserted is from array index 1. Okay, so you can see here, okay, top is a function that is used to access the top data elements, insert or remove the data element from the top. Okay, while adding or removing a data element, okay, top will take the place of first array element index 0, that is top 0, that is this one. Okay, so when adding or removing a data, okay, so then the data value will be stored in second array element, that is array 1, which is this one. Okay, so data storage will start from the second array element. Then top element is left open for data insertion and deletion. Okay, so here the algorithm, okay, comparison, if top equals to max, okay, then print stack is full, then it will go to step 4, that means end. So since data cannot be inserted because stack is full, okay, so the program will not execute. So here max element is 5, that is counting from here 1 2 3 4 5, there are 5 array elements, right? So max element is 5 and top is at number 5th, because here if you see the position of the top, okay, it is at 1 2 3 4 5, right? So which is 5 equals to 5, right? Then in that case, since there is no more element empty to store the data, so it will print out stack is full, okay, and no data elements can be inserted. Okay, what if suppose there are some empty elements to store the data? Okay, so that is in this diagram I will explain. Okay, so if top is not equal to max, okay, so here in this diagram you can see that, okay, there are only two data elements here, that is array index 1 and array index 2. As you can see that the top is in the 3rd position, right? And there are 2 data elements which are empty. Okay, so like I said, okay, top points to the address of the last data element that was inserted, right? So it will be right next to that last data element. Okay, so that's why you have 2 data elements and empty. Because this, how do we know that you have to? Because when you declare the array first, you must declare the size of the array, right? That is array, suppose like 5. So the size of the array is 5, but here you have only 2 data inserted, so top will take the 3rd position. So this position will be kept open. So when the data is inserted, okay, so here the max element is 5 and top is at number 3. Top is not 5 here. Okay, so which means top is not equal to max, 3 is not equal to max, right? Then what will happen if you insert a new data? So here I've inserted a new data in the 3rd array element, that is 2, right? So now top takes the index position of the array element. Okay, so in the first array element 2 will be inserted. So you can see that, okay, top moves from here, from the third data element to the top higher up, right, to the next element. So you can see that as the data gets inserted, okay, the data element also gets occupied. So you have only one element left to be to enter the data, right? So this way, okay, so inserted and top moves one place up, so it moves one place up. Okay, so what happens, that is this algorithm. So top equals to top plus 1, so top moves one place up, right? So that is shown by this algorithm, top equals to top plus 1, and then stack top equals to value. So which is the top of the stack here, that is ARR1, right? So that there the value will be stored here too. Okay, so since it is in the format of last in first out, all right. Okay, so go through these diagrams, okay, go through the definitions, okay, try to understand this diagram nicely, okay, and then practice on the program that is there in the textbook. Okay, it's a lengthy program, okay, but you don't need to memorize that, you just type out and check the outcome of that program. Okay, so that will be all for today.